Hello, illustrious elucidation, chemistry graduate. Let's go. Kingdom of Science arrived in the Australian state Queensland to get aluminum for the body of the rocket. The aluminum is obtained by processing the red rocks bauxite that covers the Australian ground. There are also talks about the fact that the space trip will be one way, and the astronauts will be petrified on the moon and will wait for the rescue with better spaceship. But that's not really my business, right? I'm here to explain the process of turning the red bauxite into aluminum, as seen in this diagram. Even though they say they will do it in Japan, looking a few chapters ahead, this is the chapter with the most detailed explanation on the aluminum making. First, the bauxite is processed into alumina or aluminum oxide, using sodium hydroxide. This is also known as Bayer process. Bauxite contains only 30 to 60% aluminum oxide. The rest is impurities like silica, iron oxide, which makes the color reddish like rust, and titanium dioxide. Aluminum and aluminum oxide has a special property. It is amphoteric. It means that it can react with acids and bases. Normally, metals and metal cations cannot react with base or forming insoluble hydroxide in base. But aluminum oxide is different. Aluminum oxide is soluble in base, forming the complex ion aluminate. This means that the things that are insoluble become precipitate or red mud that can be filtered out. To get the aluminate back out of the water, just crystallize it. In addition to this process, I would like to point out that the sodium hydroxide itself is obtained using electrolysis, like what we saw back in Season 1. Maybe with more advanced apparatus than Season 1, especially the membrane to separate hydroxide and chlorine. But the heart of it all is still electrolysis, and that adds to the hefty electricity bill set in the diagram. Before going to the center of this diagram, which is the aluminum, I think it's better to explain this side first, the fluoride side. Kohaku said, this is how it's getting used, but how exactly? To my knowledge, what we seek from the fluoride is the atom F, fluorine, which forms many reactive compounds due to its properties. The fluoride can mix with sulfuric acid to form hydrofluoric acid. Because F is the most electron-hungry atom, the HF bond is pretty strong, and that means the H+ cannot go away easily, and that means HF is considered weak acid. However, don't let that category fool you. It is still corrosive and causes serious burns to skin. I'm actually expecting this gag or joke to return, with Suika now grown up and Kohaku having seen it all. This HF is the one used to make the ingredient for the next step, cryolite. Use this HF with the sodium aluminate from the previous Bayer process. In the center of this diagram, we have the aluminum, which is obtained using a lot of electricity according to the diagram. This is called Hall-Héroult process, and it is an electrolysis reaction that requires molten salt, just like magnesium from bittern used in flare. Just like what I said back in the flare episode, no cheating by substituting molten salt with aqueous salt solution, because the cathode will reduce the water instead of the metal cation. The problem is melting alumina is very tough, because it requires temperature above 2000 degrees Celsius. So here we use cryolite instead, which melts at around 950 degrees Celsius, and dissolve alumina in it. The sodium from cryolite shouldn't be a problem as sodium is more difficult to reduce than the aluminum. Besides the melting point concern, cryolite dissolves alumina well, and has lower density than the molten aluminum produced, so the aluminum will sink at the bottom. As for the electrodes, both the cathode and the anode are carbon. In the anode, the carbon is consumed because of this reaction. Besides the carbon and oxygen, a bit of the fluorine from the cryolite may be released in the heat of things, so that's what the fume hood is for. In the cathode, we got the molten aluminum. From this equation, it is now clear that for an atom of aluminum we need 3 electrons. And that means we need a lot of electrons, and passing a lot of electrons means high current, thus the massive electricity bill. In conclusion, it's possible to purify bauxite into alumina using sodium hydroxide because aluminum oxide can dissolve in base and leaving behind red impurities. The fluoride is used to make a dangerous acid, which in turn makes the artificial mineral used as solvent for Hall-Héroult process. Said solvent reduces the temperature requirement, and by consuming 3 moles of electron and some carbon for every mole of aluminum, molten aluminum is produced, which together with copper and magnesium as alloy, becomes the body of the rocket. That's all I have for now. I recommend this video next because it's also about extraction of metals.